Math analyzers. This is the one you've been waiting for. Solving quadratic equations by quadratic formula. It's chapter 6, lesson 4, and man, oh man, quadratic formula, you know I'm in my glory with this guy. Because the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, is the best. So there it is. The quadratic formula is derived from if I took this guy right here and completed the square on it. So if I divided everything by a, if I then took the b value and divided it by 2 and squared it and added it to both sides and then turned that into a binomial squared and then took the square root of both sides and then got x all by itself, this is what you get. So what that means is that quadratic formula solves any quadratic equation you run through it. You just have to have it in standard form. Ax squared plus bx plus c equals 0. So that's it. You take the a, the number in front of the x squared, the b, the number in front of the x, and the c, the number by itself at the end, and you plug them in for a, b, and c in the formula. And then you just simplify. So even if the quadratic is factorable, you can run it through the quadratic formula and get out integers or fractions. Even if the quadratic formula is not factorable, you run it through the quadratic formula and you get out your irrational answers. If the quadratic formula would result in an imaginary, you run if the quadratic being solved results in imaginary, run it through, that's what you get for your answers. Okay? We're going to talk specifically later on about this b squared minus 4ac as a special piece of the quadratic formula. Okay, but in each of these examples, what I've done for you is I've left space so we can use the quadratic formula ourselves, and then we'll check our answers with something that I've already done. So here we'll be able to check our answers at the end. Okay. Speaking of, it is in standard form, so let's begin by naming the a, which is 1. The number in front of x squared is 1. The b, which is 2. The number in front of x is 2. And the c, which is negative 8. So we take the sign too. Don't forget that part. Now, rewrite, because you want to make sure you have it memorized, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And then each of these spots, we plug in one of these numbers. So we get negative of 2 plus and minus the square root of 2 squared. Put that in parentheses to square it, just in case it's negative and you want to make sure you square it correctly, right? That's where I see a lot of mistakes. Times 4 of minus 4 times 1 times negative 8. This is where I see a lot of mistakes too, and I'll point it out. All divided by 2 times 1. Okay, so I mentioned that there would be mistakes here if you don't put the negative in parentheses and square. There's also mistakes back here because, see, this is a negative 4 times 8 times negative 8. Times 1 times negative 8. So what do you get? You get a positive 32 out of that. So you want to make sure that those signs are all happening. You can double check using your graphing calculator with these things. So here's my graphing calculator. I can plug the discriminant, the stuff under the radical, in. As long as I do it in the correct form, it'll give me all of the radicals simplified. So see how I'm putting it in exactly how I wrote it in, which includes this being a negative 8, and then it'll figure that whole thing out for me. So there's a point where we got a discriminant and it's a perfect square. When your discriminant is a positive perfect square, it means you get 2 rational roots. So let's finish and make sure that's the case. Well, we can take the square root of 36. We get 6. So negative 2 plus and minus 6 divided by 2. That can all simplify. Negative 2 and 6 are both divisible by 2. So I'm going to get negative 1 plus or minus 3. Well, negative 1 plus 3 is 2. And negative 1 minus 3 is negative 4. And that would be my 2 answers. -4 and +2. And is that what we were supposed to get? Yes. Had I factored this thing, which of course was probably quicker, I would have gotten -4 and +2. And then it showed you this part, which showed you that part, that middle step. I plug this into the graphing calculator, partly because later on when I teach you specifically about the discriminant, I just want you to kind of be used to plugging the discriminant stuff in and figuring out, oh, look, that's a positive perfect square. I'm going to get 2 rational roots, which I did. Roots, by the way, another phrase for answers. Roots are when we touch or cross the x-axis. So, that might mean something here. I'm not even subtle about it when I'm pointing this stuff out, right? Already standard form, sweet. Let's find our A and our B and our C. So easy. A is 1, B is -4, and C is +4. So let's plug in again. X equals -b plus or minus the square root of b squared minus 4 times A times C, all divided by 2A. You'll memorize it like me someday. And then you'll just recite it wherever you go because it is the best formula on the planet. Duh. Negative of -4 plus or minus the square root of, make sure you put it in parentheses, -4 squared minus 4 times 1 times 4. That'll be interesting. All over 2 times 1. Okay, well, the negative of -4 is +4, so that's what's out here. Now, -4 squared is 16, +16, right? And then look here, -4 times +1 times +4, that answer back there is negative, right? So that's a -16. What's 16 minus 16? 0. So let me just prove that to you, plugging into the graphing calculator just to remind you that this is a possibility and this is what I would do if I were just in the zone doing this, right? Not teaching it right this moment. Look at that. If your discriminant is 0, you get 1 real root, usually rational as well. But 1 real root is what we usually call it, okay? So this is the square root of 0 over 2 times 1 is 2. Well, we know the square root of 0 is 0, and there is no positive or negative 0. It's just 0. Doesn't have a sign attached. So this is just 4 over 2, which of course divides to give me 2, right? So my answer here, 1 real root, 2. And it does say that right here. When the value under the radical, the radicand, is 0, there will appear to be only one answer, okay? That's because plus and minus is gone. So we call this 1 real root as the answer, okay? That's because this was a perfect square trinomial, so it factors into 1 binomial. So there's 1 root. What that will mean later will be 1 touch to the x-axis, okay? Oh, I'm just going through all the types. I'm even touching on discriminant with this video, so later on when we talk about discriminant, you'll be pretty well prepared, right? In exercise 3, we do not have standard form this time. Of course not. We got to subtract the 7 over. We get x squared minus 3x minus 7 equals 0. Now you can say A is 1, B is -3, and C is -7. So see how it matters? It matters to get that standard form because it matters to get those signs here. So now x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now let's plug in. So negative of -3 plus or minus the square root of -3 squared minus 4 times 1 times -7. Okay, so that back will be positive, all divided by 2 times 1. I get +3 up here, plus and minus. Let's simplify the radical, plug into the graphing calculator right here. So -3 squared minus 4 times 1 times -7 gives me a +37, but 37 is not a perfect square. So a positive non-perfect square means two irrational roots. And that makes perfect sense because right now, I can't simplify 37 under the radical. So I leave it. And then I look and I've still got this 3 out here and I've still got this 2 down here. And guess what? That is my final answer. It's 3 plus radical 37 over 2 and 3 minus radical 37 over 2. Those are my two final answers. Of course, you're more than welcome to write just 3 plus or minus radical 37 over 2. That's irrational. That's it. And that's as simple as it goes. Sometimes they're that quick, right? It's actually kind of nice when you get an irrational number like that that can't simplify any further because you're done right there when you simplified everything. There's no more reducing or anything like that. So it's kind of nice. All righty. Oh, now this is the fun part. So, as I mentioned, I'm going to prove to you that the quadratic formula comes from completing the square on standard form. So this is a little zany, right? But that's what we're going to do, and we're going to prove that the quadratic formula is just like completing the square. It starts with moving the c to the other side of the equal sign, and we'll leave a plus blank in its stead. Oh no, I've got another issue. Can I have the a? Actually, let's start there. Let me do that for you. Let's start there. Can I have the a in front of the x squared? And that's where I'll start this. And what I'll do is I'll divide the a out of everything to start, okay? So that you're left with just an x squared, but you got to bring down this bx over a. And you got this c over a right here equals 0, because 0 divided by a is still 0, right? So I'll start there. I got to move this guy away, so let's subtract him over. So I get x squared plus bx over a plus blank equals negative c over a plus blank. So we'll add whatever it is to both sides, right? Whatever it is to complete the square. Okay. Take this guy, b over a, divide it by 2, which means multiplying it by 1/2, and then we square that answer. So really we get b over 2a squared is what we want to put in the blank, and that's b squared over 4a squared. So that goes in the blank there and there, right? Because we squared those things. So let's just rewrite Okay, looks a little yikes right now. I get that. I feel that too. The beauty of it, though, is that this is a perfect square trinomial right now. This is a perfect square trinomial right now. And the way that that factors, it's just going to factor into one binomial squared. So I'll just do that right off the bat, and then that'll be helpful to like getting some terms down to size. The way that that always factors is this value right here. Obviously, this is going to be our x, right? This value right here is always before you square, that spot where you divided by 2. So this is just b over 2a right there. And when I go to take the square root of both sides, that's what's going to be left. Okay, so don't worry yet. Now, the only problem over here is I've got to get the same denominator right there. Okay, so let's take this and multiply top and bottom by 4a. So let's take negative c over a and multiply top and bottom by 4a because we need to have the bottom be 4a squared. So there was already an a there. So now let's get that 4a squared like we want. We want that to be that, but the top has to match. So it'll be, if I go in order, negative 4ac. And things are probably going to start to sound familiar now, aren't they? So let's take that and place it right here. So negative 4ac over 4a squared plus b squared over 4a squared. Well, now that those two have the same denominator, I can add their numerators. Okay. There we go, where I made that change. So just so you know why I did that on the side, right? So now that they've got the same denominator of 4a squared, I can add the numerators together. And let's put that b squared first, maybe, to start to get a little bit familiar. A little bit familiar notation. Bring this guy down. And now, because I've got him in a binomial squared, the opposite is taking the square root, so I do it to both sides. Now, when you take the square root of something like this, you have to put your plus and minus in front of it. The top can't take the square root of, so let's leave it as the square root of b squared minus 4ac. But the bottom, the square root of 4 is 2, and the square root of a squared is a. It's all sounding so familiar. Bring down x plus b over 2a. And now the last thing to get this formula, so x is all by itself, is subtract that b over 2a over. Move it over. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a, because look, it was the same denominator. Huh. Bam. Best formula in the world. Best formula in the world, and you can see why it's the best. This, of course, is the discriminant in here. I've mentioned that word a couple of times. We'll have a lesson all about that. The inside stuff is the discriminant. This stuff right here is actually the axis of symmetry formula, which you might remember from Algebra 1. And if not, we'll have a lesson on that here in Math Analysis. Part of the other part of why this is the best formula ever, right? And just in case you didn't believe all that work that I just did, excuse me, really zoom out. There it is. Best formula ever. Guys, enjoy using the quadratic formula now that we've got it again. It's great to have it back in our purview, isn't it? You're going to love it. We'll start using it, and then we're going to start reviewing all of our methods to solve quadratic equations in the next lesson. So we'll do like a real big overview of everything. But there it is, all the work I just did, right? All right, kiddos, have fun with my favorite formula, and I shall be seeing you. Bye.